this video, I want to discuss defining general angles and using radian measures. First, the vocabulary. In a coordinate plane, an angle can be formed by fixing one ray called the initial side and returning the other ray called the terminal side about the vertex. An angle is in standard position if its vertex is at the origin, its initial side lies on the positive x-axis. So in the diagram below, we can see an angle in standard position, and we can see our initial side. We can see our terminal side. Coterminal angles are angles that have coinciding terminal sides. 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc of length r. In other words, the length of the arc is the same length as the length of the radius. A sector is a region of a circle that is bounded by 2 radii and an arc of the circle. It's almost like a piece of pie. A central angle is the angle formed by 2 radii. Example 1. Draw an angle with a given measure in standard position, 240 degrees. So first take note, we start at 0, then we go to 9, then we have 180, and we see 270, but we don't quite see 240. So if we think 240 is between 270 and 180, so we do 240 minus 180, that is 60. So what we need to do is add 60 to 180. So this 60-degree angle here, and all the way around, we get to 240, and there's our 240-degree angle. Okay, we asked for a 500-degree angle. So we have, if we make one rotation around, that's 360. So what we need to do is do 500 minus 360. And 500 minus 360 should be 140. Yes, 140. So going back around, it would be a little bit past 90. So add 50 to 90. So here's our 50 degree. We're going to approximate this to be 50 degrees. So to get to the 540, we go around once, go around twice, and there's my 500-degree angle. And keep in mind, we're going clockwise. To get negative 50, negative angles mean go clockwise, whereas positive angles go counterclockwise. So to get to negative 50, we need to go back 50 degrees. So this will be my negative 50-degree angle. And we're done plotting angles. Example 2, find one positive angle and one negative angle that are coterminal with negative 65 degrees. So first, negative 65 degrees will be in between, remember it's going to go counterclockwise, so this will be our negative 65 degrees. So here's our negative angle. So that's negative 65 degrees. So what we want to do first is find our positive. To find our positive, we're just going to do negative 65 plus 360. The negative 65 plus 360 is is 295 degrees. So going in the positive direction, that's 295 degrees. We get our negative. We're going to take negative 65 and we're going to subtract 360 degrees. And when we subtract, I'm going to get negative 425 degrees. So going all the way around, we get 425 degrees. And there's our one positive, one negative. We want a positive and negative angle at our coterminal at 410 degrees. So first 410 degrees, remember going around once gives us 360 degrees. So keep in mind, first we want to figure out what that angle is. Then we have to, so 360 will be 50. So we want about a 50 degree angle. So here's our 410 degree angle. Now we want the positive angle. So what we're going to do is do 410 minus 360. And that will be equal to 50 degrees. So just the 50 degree part. We'll do that in red. There's our one angle. And then let's do our next one. We'll just change color. To do our negative, we want to do 410 minus 2 times 360. So that's going to be like 410 minus 720. And that is negative 310. So working our way backwards, there's negative 310 degrees, and we have our positive and negative angle. Converting between degrees and radians to degrees. So when you're converting from degrees to radians, you want to multiply the degree measure by pi over 180. When you're converting from radians to degrees, you want to multiply the radian measure by 180 divided by pi. So let's do an example. We want to convert 165 degrees to radians. So we're going to do 165 times pi over 360. So the degrees cancel out. That's 165 pi over 360. What we're going to do next, we just want to try to simplify that fraction. So if we do 165, let's try dividing top and bottom by 5. If we divide top and bottom by 5, we're left with 33 pi. Because 165 divided by 5 is 33. And 360 divided by 5 is 72. So 33 pi over 72. I think we can do a little bit more. So let's try dividing by 3. We know 33 goes into 3 11 times. So that will be 11 pi all over 72 divided by 3 is 24. So 11 pi over 24, and we've finished simplifying our radian. Let's change colors. This time we're converting negative 3 pi over 20 to radians. So we're going to do negative 3 pi over 20 times 180 degrees over pi. Our pi's are going to cancel out. So negative 3 times 180 would be negative 540 all over 20. And then we're going to, don't lose the degrees. We're going to divide it by 20. So we're left with negative 27 degrees, and we're done. Part C, 1 degrees is how many radians? Or sorry, 1 radians is how many degrees? Let's grab a new color. Let's go with lava. So we're going to do 1 radian times pi on the bottom, 180 over pi. And remember, this is radians. So my radian cancels. So all we left to do is just do 180 divided by pi. It is going to be a decimal since pi is an irrational number. So in the calculator, you do 180 divide pi, and I get 57 point, we'll round to 2 decimals, 30 degrees, and we're done. Finding arc length and arc of a sector. So when we're finding arc length, that's pretty much the outer perimeter of a circle. So the distance from 2 points, like for example, a famous problem for finding arc sector was when Eratosthenes tried to measure the circumference of the Earth when he measured the distance of a shadow in 2 equal distance when he knew the distance between 2 points on the Earth when in Egypt in ancient times. So that would be a good example of arc length, finding the circumference of a circle, but only a section of a circle. So if theta is measured in degrees, then the formula is arc length equals theta divided by 360 times 2 pi r, where r is your radius. If theta is measured in radians, then it's just theta times r. For arc sector, that's just like finding the area of a piece of pie. So if theta is measured in degrees, and the area of a sector is theta divided by 360 times pi r squared. If theta is measured in radians, then area of a sector is 1/2 r squared times theta. Let's look at 2 examples. A person is standing on Earth notices that a 747 jumbo jet flyer overhead subtends at an angle of 0.45 degrees. If the length of the jet is 230 feet, find its altitude to the nearest 1,000 feet. So to solve this, we need to figure out which formula to use. So this is an arc length formula. So we say S equals, this is in degrees, so we need a degree formula. So that would be theta over 360 degrees times 2 pi r. So let's start plugging in what we know. We know that theta is 0.45 degrees. So we say 0.45 degrees all over 360 times 2 pi. We don't know our r. We do know the arc length is 230 feet. So let's start simplifying this mess. So 0.45 divide 360. Is 0.00125 times 2 pi r, and that's equal to 230. So we have 230 multiplied on the right side equals 0.0025 pi r. We'll divide both sides by 0.0025 pi. And then once we divide, we know approximately how the plane is. Since this is such a small radius, we'll assume the height is the radius. 230 divided by 0.0025 times pi, and we get r is approximately equal to 29,284 feet. And we're done the first example. Example 2, a lawn sprinkler, example 5, a lawn sprinkler located at the corner of a yard is set to rotate through 90 degrees and project water out at 30 feet. To 3 significant digits, what area of the lawn is being watered by the sprinkler? So first we are in degrees. So we need to use the degree formulas, and we use area of a sector. So we'll just say S equals 90 degrees divided by 360 times pi r squared. So we'll just say, use L for area of a sector. Sorry, A, we'll just use A. A equals theta over 360 times, let's write down our formula, pi r squared. Times pi r squared. So 90 divided by 360 is just 1/4 pi r squared. And we what else do we know? We know that a lawn sprinkler at the corner of the R is set to rotate through 9 degrees and project out water at 30 feet. So that means our radius is 30 feet. And 30 squared is 900. So what we'll have to do is just multiply. So let's consider this as 900 divided by the 1/4 pi r. Pi times 900 as 900 divided by 4. And that's 225 pi times that by pi. And we have the area of the sector to be approximately 706.85 feet squared. And we are done with the area of the sector in the arc length problem.